Good morning and welcome back. Here we have question number 6 for the 2019 FRQ Calculus AB practice exam. Once again, no calculator. All right, let's go ahead and get started. So we have an equation right here, and we're supposed to show that dy dx is equal to this. This means that they already gave me the answer. I just have to get to it, right? I'm just gonna be doing implicit differentiation. Implicit differentiation. And we're going to be differentiating with respect to x. That means if you see a letter that is not an x, you're going to have to derive it. For example, the dx of y is going to become dy dx. The dx of m is dm dx. That's just an example. We don't have an m in the equation. But if something is not an x, it's going to look like this. All right, let's get started. The derivative of 2x squared is 4x. The derivative of 3y squared, it's 6y times dy dx. This is where you have to use your chain rule and your implicit differentiation. Minus 4. And I'm going to handle the x and the y away from the 4. So I guess think about me factoring out the 4. So in parentheses, we're going to do the product rule. And it's the first times the derivative of the second plus the second times the derivative of the first equals 0. Okay. 4x plus 6y dy dx minus 4x dy dx minus 4y is equal to 0. Next, I'm going to isolate my dy dx's. So these guys are going to stay on the left side of my equation, but I'm going to move everything else. 6y dy dx minus 4x dy dx equals negative 4x plus 4y. Since both pieces on the left side of the equation have a dy dx, let's factor it out. By factoring out a dy dx, that allows me to just divide by this factor right here, the 6y minus 4x. And isolating my dy dx, which is the goal of this question. So now we have negative 4x plus 4y divided by 6y minus 4x. But that still isn't the answer, right? Because it looks like it's simplified. So we are going to go in, we're going to go ahead and factor out a 2. I'm going to factor out a 2, leaving me with negative 2x plus 2y divided by 2, 3y minus 2x. Is this what I'm supposed to get? Yes, it is. The 2's cancel each other out. And there it is. Oh, that's an X. Even though the numerator is in a different order, still the same thing. So that's done. Find the slope of the line tangent to the curve at each point where the curve is equal to 6. Okay. Well, since my derivative dy dx is already given to me, oops. And here's the thing about this question. Even if I didn't get the first part correct, I could still work on this question because I'm already given the derivative, right? So I just go ahead and recycle it, what was given to me. So if I want to find the slope where x equals 6, notice how we're going to have some y values. So before I even start finding the slope, I think the first thing I should do is find my y value. So I'm going to go back to the original equation, 2x squared plus 3y squared minus 4xy equals 36. And I'm going to use the 6 to find y. So this is going to be 2 times 36, which is 72. Oh, good morning. All right, so now from here, it looks like I have a quadratic, right? So why don't we combine some like terms right here? We're going to take away the 36. So we have 3y squared minus 24y. 72 minus 36 gives me 36. This is a quadratic that I don't want to factor, or I don't want to try to like work with right now. So instead, what I'm going to do is I'm going to take out the greatest common factor to hopefully simplify my problem. It's much easier to work with a quadratic with a leading coefficient of 1. So if possible, always take the greatest common factor. Now the next question, is this quadratic factorable? Because if it's not, we're going to have to go through the quadratic formula. Two numbers that multiply to 12 but add up to negative 8. Negative 6 and 2. Perfect. Separate them. Set them equal to 0. And there we go. We actually get two y values. The question says, find the slope of the line tangent to the curve at each point. So they were kind of already hinting, right, that there was going to be multiple points. So the first point, the point 6, 6, taking the first y value. The slope of the tangent line dy dx is going to be 2 times 6 minus 2 times 6 divided by 3 times 6 minus 2 times 6. Did I do that right? I think I did. Dy dx equals 12 minus 12 divided by 18 minus 12. The slope is 0. That's the slope of the tangent line at the first point where x equals 6. But there's a second one. The second point, the point 6, 2. Dy dx equals 2 times 2 minus 2 times 6 divided by 3 times 2 minus 2 times 6. 4 minus 12. 6 minus 12. Simplify it by 2. And we get 4/3. That's the other slope at the other point. Okay. C. Find the positive value of x at which the curve has a vertical tangent. Show the work that leads to your answer. Okay, so what do we know about vertical tangent lines? We know that the slope is undefined. And the slope can only be undefined when the denominator is equal to 0. So that's what we're going to do. We're going to take, here's my work, dy dx should be undefined. I know I'm kind of just rewriting what I just wrote, but like that was the thought process, and here's the work that I would show. Normally I wouldn't write this, and if I was doing the test myself, that's just me thinking about it. Then I'm going to say, what was my derivative? 2y minus 2x divided by 3y minus 2x, again, should be undefined. And I already know that I need the denominator to be 0. So then I would take my 3y minus 2x, make that equal to 0. Now I just solve. And I get y equals 2x over 3. Now this isn't an answer, right? Because I'm supposed to find a positive value for x that creates this function or the slope to be undefined. Well, now that I already have an expression for y, here, this was my first step. Now I'm going to go back and I'm going to go to the original function, which is 2x squared plus 3y squared minus 4xy equals 36. And I'm going to substitute it. This is going to create an equation in terms of x, and I'm going to be able to solve for x. So 2x squared plus 2x over 3 squared minus 4x times 2x over 3 equals 36. All right, let's simplify. This is going to be, well, if I square this, that's going to be 4x squared over 9. So I'm just going to call it 12x squared over 9. And then we're going to, when we multiply these guys, we're going to get 8x squared over 3, which is 36. Okay. Looks like I might have to get a common denominator. Maybe. Yeah, let's just work it out. Let's see what happens. Reduce it by 3. Combine my two fractions. That's going to be negative 4x squared over 3 is equal to 36. You can get a common denominator, or you could just multiply the entire line by 3. Really, whatever you want to do. I'm just going to multiply by 3. The whole line. So that's going to be 6x squared minus 4x squared equals, this is 108. 2x squared equals 108. I should have written a little bit smaller. Here, let me take off my thoughts. Too much. Okay. X squared equals 54. X equals the square root of 54. Technically, it's a plus or minus square root of 54, but we are supposed to find a positive value of x. So you can leave it like this, or you can even simplify a little more if you want. 54 is 9 times 6, and the square root of 9 is 3. Any of these answers should be acceptable. That is the positive value of x that makes our slope undefined. D. Let x and y be functions of time. Oh, there it is. That's a big thing right here. X is a function, y is a function of time. At t is equal to 1, x is 2. Here, I'll even write that. X of 1 equals 2. The value of y is negative 2, which means y of 1 equals negative 2. The value of dy dt is 4. Find dx dt. So we're back to doing implicit differentiation. But this time we're doing it with respect to t. So that means that every time you're taking a derivative of a letter, you're going to get dx dt. Or not just dx dt, right? But like whatever the letter is, dt of w is going to be dw dt. And that's what you got to keep in mind when you're doing implicit differentiation. Because what I'm going to derive is an equation of x and y's. So let's write it out before I start finding my derivative. Okay. So now we're gonna derive with respect to t. We're gonna get 4x times dx dt, 6y times dy dt, minus 4, and then we're gonna do a product rule. The first times the derivative of the second plus the second times the derivative of the first is equal to 0. And because I am given some values, I'm not even going to try to simplify this down. I don't really want to isolate the dx dt. I'm just going to go ahead and plug in numbers. So 4 times 2 times dx dt plus 6 times negative 2, and then dy dt is 4, x is 2, dy dt is 4, y is negative 2, and dx dt is what I'm looking for. Okay. Let's take it one step at a time. 8 dx dt minus 48 minus 4 times 8 minus 2 dx dt. We're going to combine some stuff right here. And we're also going to combine these guys. But you know what? Let's move it to the other side. So it's going to be negative 80. So they become positive 80 once we add them. Let's reduce this. Looks like we can reduce by 8. 5. Dx dt is equal to 5. You get 3 points out of this question. 1 for doing implicit differentiation. I think you're going to get another point for doing the product rule or the chain rule. And then finally the point for getting the answer, which is 5. But yeah, that covers question number 6. Thank you again, and I'll see you next time.